Right. Good evening, everyone. Although there's really no one, but good evening, everyone, and welcome to the 2026 Day 3 March Madness. And in Day 3, in today's lesson, we're going to try to recreate the double story structure that we've been using in Revit. In our previous video in Day 2, what we did was we reviewed some of Day 1's information. We put um, the views, the floor plans, the sections, the elevations. We had put them on a title block, and then we had exported um a structure view. Should have been a foundation plan from Revit, and we had exported it into a DXF, and we had used that, and we had imported that DXF file into Proto structure. We imported it and then we worked with it because when you import a TXF file into Proto, you can be able to load in, as long as you're on different layers, you can be able to import grid lines, grid IDs, and structural columns. If you incorporate some beams, some structured beams also. And in that video, we ended by saying we would be adding levels to the proto file. But before we actually do that, I received some messages, and also it was concluded that it would be nice if we could actually recreate the structure, because the way that we started it, it's almost as if I just gotten a structure from one of my folders or from one of my previous jobs, and then I just started it out of thin air. Participants said it would be nice if they could actually recreate the structure in Revit by themselves. So that's what we are going to try to do, or actually, that's what we are going to do in Day 3. So I'll go to my desktop here, I'll go to 2026 March Madness. I've got some Day 1 information teaching material. I should actually include a Day 2 folder, right? And then a Day 3 folder for today. So what we're going to do is we're going to get some of the teaching material information. I think this should be the combined PDF that we had created in day 1. And as you can see, it's got 2 sheets. The first sheet, or the first paper, is being called the floor plans paper, and it's got S101, S for structural, 101 paper, or maybe 100, or G would be like the cover. And then the second is 102, and it's got elevation views and a section view. And we called it Mr. Nathan Peary's double story. This is essentially Nathan Peary, one of the participants. And then we had shown how you can change all this information in Day 1, and I think some parts of Day 2 also. So here you can see we've got a part foundation, and we also have a strip foundation, and we have ground floor and the first floor plan, and also section views and elevation views. When you zoom in, you can see that these are some elements of a window, and also cuts the staircase and also the door. You can see that these are double hatched walls. These are foundation walls, and this is a solid field. And then we've got the strip footing here, all of it. And we also have the isolated part foundations, including the stub columns ending there, you see. So all this information is helpful. And we're going to try to recreate this structure from these two uh, sets of drawings. So what I'm going to do is I'm going to go to my Revit, and as you can see, we already have that existing structure. So the goal or the agenda is to try to recreate this structure. So what I'm going to do is I'm going to uh, go on my file tab, and I can create a new project, right? Suppose you are not working in a suppose you are not working in Revit, because for me this video starts out with my Revit already open, and also there's my proto, right? So what we are going to do, and also the AutoCAD. So what we are going to do is we are going to open Revit like that. Open it from start, and I'm using Revit 2024. You can give it some time. There it is. So when you open it like that, you have takes you to the home page over here. And then if you've created any projects, you'll see them in the model space there. If you've created any families also, like the O0 metric title blocks that we have done, you'll see them here. So what I'm going to do is I'll actually go to new. Open is for when you're trying to open a model that you've already, or a drawing that you've already, or a project that you've already worked on. So I'll go to new, and I will not choose a construction template. I'll choose a structure template, and I'll say okay. And so this is your user interface. Some of you have your project browser over here. If you'd like to make it look exactly like mine, you can drag it over here. And also, for the purposes of this video, I personally have a template that I've created for myself that has my choice of font style and font text and some company notes and information that I use, especially for the title block. But for this particular project, or for this particular lesson, we will not be using that one. We'll be using the generic Revit template, right? Like the more that you design, the more that you draw, the more that you're gonna want to have a particular specific template that works for you as an individual, for consulting firm that you may be working with, or for, and so on and so forth. So what I'm going to do is I'll put this over here, and then I'll open the WPS PDF reader, okay, so that we can be working through this together. So what I like to do before I can actually start working in my floor plan, because here you can see it says structure plans, and you've got level 2. What I like to do is I'll go to either a section or an elevation view, and I'll set out the heights, the levels, because when you're placing items, you're going to be placing them with an association to that level. So what you do is you can either go to the south there, and it shows you, maybe for the purposes of this video, since we're going to have this back to back, and that works, but personally I prefer to have it like that. Maybe we can dock it over there. so that we have enough room. So here, when you zoom in, you can see that your foundation, the top of foundation, because this is the pad foundation, right at the top of the pad foundation, the distance from the finished floor level is about 1500, right? So what you can do is you can right left click one of these, just click on it, and then you right click and you say create similar. And what you want to do is choose the pick lines. So you're going to be picking this one, but then you offset it 1500 below. So you can either pick it on to go above or pick it to go below. And what I'll do is I'll click right there, and as you can see it says FFL, finish floor level 1500. I do not want it to say FFL. I actually want it to say maybe TOF. So you can double click and go to rename if you like, or you can click on this and say maybe -02 and say TOF, meaning top of foot. And Revit will ask you whether or not you'd like to rename this corresponding view over here, this level 3. And when you say yes, you can see it says -02 TOF. Okay, mind you, you can select that, the elbow, okay, like that. One other thing that we need to include is, because the strip foundation does not sit on the same level as the isolated pad foundation. The isolated pad foundation goes deeper because you want the columns to go further down in order to achieve a better bearing capacity. Like in order to distribute loading, the structures loading to like a better surface bed. And here, maybe a geotechnical engineer would have established that at -1500, you have better bearing capacity. If you have a lot of material, and if the client is a client of means, you can put the strip foundation on the same level as the pad foundation. Why I did this in most cases is because you do not want to use. What this implies is that if the strip foundation and the pad foundation are on the same level, meaning also the foundation walls will need to go deeper there. Meaning you need more courses, you need more material, you need more cement, sand, quarry, you know, all of that. So if that's not your intention, and you know some of these load bearing walls actually are not going to be bearing a lot of loading, you're better off putting it like at -800 to have like three courses, because each course is about 200. If you're watching this video from Zambia, you know the current blocks that we have, usually most people will be using like 6" or 8". And whether you're using a 6" or 8" block, you know the thickness is about 200, right? Or 150. Yeah, but the height will remain a constant. It will be 200. So you select this again, you say create similar, you do the same, you pick, you're trying to offset 800 below. So when you select, this is top of footing, this can be strip foundation. You can say this is 01. You say strip footing or strip foot, you rename, and see how they are following each other properly. If you wanted to, you could also break this like that, and you can put that one over there to just have like a distance. And so now you have the the finished flow level at 0 0. So you can rename this. You say 0 0. You can say FFL, finished flow level, and you rename. See how they are following each other. And then after that, you can say first flow finished flow level, and it's going to be at 3,000 meters. That's okay. As you can see right now, this template is in meters. If you'd like to change it to millimeters, just press UN and change the length to, oh, it's already in millimeters. Okay, of course. Well, it's already in millimeters, it's just displaying these in meters. So what you can do is you can select this, double click, and say 01. This is your first flow, finish FL, finish flow level, and you can rename. Now it's here. And then after that you have the wall plate level, right? So you select this, you say create similar, you offset it also at 3,000 because you want it to be at 6,000. So you say there, you can see the distance, it says 6. So this can be 0 2, as a matter of fact. This can be 0 2, and you say wall plate. This is where the wall plate level. If you wanted to, you can also include a ring beam, but it won't be necessary. So say wall plate, and I'll rename. And finally, if I wanted to, I could say roof apex, like at the top of the roof. Here it's not included, but it can be assumed. Or maybe we'll leave it. If the architect provided you with any drawings and you can see the roof apex, you may include it in the same manner in which we included these other ones. Okay, so now that we've set out our building heights, we can go back to our isolated part foundation layer, and we go to TOF because this is where we're going to be working from. This is where these footings will be on the TOF level of view. And then after that, you can incorporate some grids. So you go to your architecture tab, you go to data here, and you click on grid, right? So when you click on one grid here, we can, like we learned in a previous video, the ones on the y-axis have got numerical values. The ones on the x-axis have got alphabetical values. So what we'll do is we'll select right here, arbitrary. Make sure you're moving in a 90 perpendicular. If you're unable to move in a 90-degree angle, just hold down shift and it will be constrained to only move in 90. So you click right there, and as you can see it says 1, and you click on it, you click on this little square, it says show bubble, you click on it, it will give you that number 1 that you're looking for. Okay, so what you can do is you can create similar, and then you can pick if you wanted to, and then offset it at 4,300, because here at the here at the dimensions you can see from 1 to 2 it's 4,300. So here I'll say 3,000 or 3.2, is it? I'll say 4,300, and then I'll click in this direction, and as you can see it gives us 2. And then on the other one here, now I have to change the offset distance. This is like 3940, 3,940, and then I'll click on it. This is 3, and then from 3 to 4 we've got 2060 or 2 millimeter 2016. Oh, not in that direction, this direction. And then from 4 to 5 you got 5850. So you just change the offset distance to 5850, and then you click. So now you got your symmetry. So you've got your system, your grid system from 1 to 5. Personally, I do not like the way in which they are sitting with regards to these elevation marks. So you can select all of them and you can just try to move them in the center like that. And then from that, you can try to dimension. You got the dimension icon over there, and then you check to confirm that what you've done is correct. So 1 to 2, 4300, 2 to 3, 3940, 3 to 4, 2060, 4 to 5, 5850, right? And then you click on the white space there. And then from 1 to 5, as you can see, it says 16150, which is similar to the dimension on our drawing here. Okay, cool. So now we can do the alphabetical grids by going to the grid line, and then now drawing a line like this. So what we were doing previously, we were offsetting, but here I'll show you that you can also just copy, like use the copy command. So as you can see, this was number 6. I do not want it to continue with the numbers. So what I've done is I double clicked to change, and then Revit is smart enough to just continue with the alphabetical. Click one, and I'll use the copy command, and then from there to B, it says 4100. So just type 4100 and enter. And then from B to C, like 300, like that. And then C to D, 700. Okay. And then from D to E is 3100. Okay. As you can see, this should be moved a little bit in that direction, just to have a good looking grid system. And then also select everything, just try to center my grid system with reference to the elevation marks. So now, as you can see, this is not legible. No one can be able to read this type of grid system because they are too close. The letters are too close to each other. So what we can do is we can select B, click on it on the elbow, and then just move it like that, right? So if we do B like that and we do D like that also, we have a better looking grid system and it's more legible now. Do the same for this one. I'll try to make them align like that. Also do the same this side and make it align with the other one on the other end, similar to what we have here. And then when we try to dimension from A to, remember you're trying to dimension from A to this side of B, not this side but this side, and it will show you that you measure the distance of 41. When you do the same for this part, it says 3, right? From this side to this side tells you 7. From there, from D to E tells you 3, 1. But then again, also here, I do not like the way they meet. So what we can do, I'm still trying to have them in one line, but I can move this other like that. And if I wanted to, I can remove the leader head like that to show Right, this is 300. And then over also, you can dimension from A to E and have it and place it over there. It says 8,200. So there's your 8,200. Okay, so if you wanted to, you can copy this so that you do not have to dimension all over again and place it uh, from there to here. I don't know why it's not copying, so I'll just do it manually. I'll say A to 1 to 2 to 3 to 4 to 5, and I'll click outside there. And then 1 to 5 also, like that. And what I did for this side, I do here also, like that. This one and this one, like that. This one and this one, and this one, like that. Also move this over here, remove the leader, and then it becomes like so. Mind you, oh, this is not saved. So let's save it in, we'll save it on the desktop, 2026 day 3, and we'll name it double story Revit structure. Here you can add spaces, not like proto structure. When you click on the options, I just need one backup. I do not want to have a lot of backups. I do not want to have a lot of files. And then I'll just save it and save. So here we've set up the grid system. When I click on the house for 3D, you can see that we do not have any elements or any structures at the moment. When you select that, you can add the bubbles so that you can be able to see the grid lines in 3D view also. 3D view also, right? If you wanted to, can you apply an elbow here? You cannot, but it doesn't matter because we've already done the elbows in the other view, like that, like that. Okay, cool. So now I can go back to my TRF and I can place some columns. We'll assume we're going to use 200 by 400 structural columns. And then, are they going to be centric or not? Let's zoom in. Yes. Here it shows we will have about 100, I guess, like for the wall. But these other ones are going to sit perfectly. The bottom ones also will be a little eccentric. Also this one. So you can place columns individually. So we're in the structure template, go to the structure tab and say column, and then it may bring up a rectangular concrete column, or you can bring up a universal, like a universal beam or universal column. So what you're trying to do is go for, these are CHSs, these are circular hollow, and then you've also got the concrete rectangular, what we are looking for. So what we'll do, we'll select this one, but then we'll duplicate. We'll click on edit and say duplicate. We do not want 300, we want 200, and 200 by what? By 400, like that. And then you say okay. Mind you, just change the name, but you haven't actually changed the properties. So on the dimensions part here, change now the values to say 200, 400, and then if you wanted to, you can give it a type mark. You can describe it. Yeah, if you know how the cost also, you can include it, but we won't be doing that in this video. So you apply, you say click, and then if you wanted to, you can place them individually, or if you wanted to, you can say on placement here, you can say place at grid, and also before you can place them, find out that you're going down. Right here, structural engineers, we place things going downwards. Architects place them going upwards, but for us, we go down. So here, actually, you're starting from the finished floor, or maybe let's go up until the ground floor, isn't it? The first floor, finished floor level. It will try to make a fuss, but don't mind. Anyway, let's try to place them without changing the parameters. You can change the parameters here, but it may probably give you some problems. So if you wanted to go up, you change to height. So for example, change to height. So now you're going up, you're not going down. And then it's from the TOF, the view in which you're working in, to I want my columns to go up until the first floor slab. So now as you can see, there's no error message. And then I'm going to place them at grids, but I'll select from 2 to 5, right? But then that will be a lot. Okay, when you do that, you can see it shows you, and then you can say finish. But here, as you can see, let me zoom in on the other side. Here I've got a problem here. I do not want my walls, like I do not want to, if I were to place a wall here as the center, this other side will protrude. So what I can do is I'll align it and I'll say from here to here, I actually just want it to be 100 so that they can flash, so that the column and my walls can flash. And then as we can see at 3, there's no column here. 3A, 3A, there's no column. Here 3A, there's a column. So let's just go in and delete this one. This is not included. 4A, it has, and it's aligned to this one. So what we can do is we can select this and use the align tool. So you select what you wish for the thing, like the mother alignment. This is what we're aligning, and then secondly, you select what you wish to align. 5 also, there's one similar. I don't know if it's a multiple. My align 2 wasn't a multiple. So select, no, select, align, select this side, select what you wish to align, and as you can see, all of them are in the same line now. And then we can move to 2, back to 2 again, but this is 2B. 2B, it's at the center. When you zoom in here, you can see that 2B is at the center. There is no 3B. So if you suppose your Revit has had a 3B, just move it to 3C. So this is the 3B. Move it to 3. Just select it on modify, select move. Move it from the center there to there. And this is what we have here. At 3, it's at B, it rests at B, doesn't rest at C. There the column system can probably, the beam system will probably be a little difficult, but we can still achieve it. 4B, we have a column at 4B there. Also, it's not eccentric, it's at the center. Cool. 5B, also the same thing. 5B. Okay, cool. We go to C now. C only has one column, and it's the same one that we moved. So let's try to confirm. C only one column. Cool. Okay, we go to D. Does D have any columns? None whatsoever. I wonder why we chose it, maybe for the walls. So all these columns that are resting on in D, just delete them, right? Because we do not have any. Okay, cool. We move on to E. E at 2E, 3E, and 5E. Only three columns in this line. So I know at 4 there's one here. I'll delete it. I don't need it. And also I need to move it a little bit upwards by 100 to align it with my wall. So I'll dimension it as that. Oh, let me delete this dimension. It's the lower section that I'm interested in. So from there to there, this is 200. So now I'll select the item, the element, the structure element, which is a column in this case. And then as you can see, if I do not select it, I cannot make changes. But when I select it, I have that little D in blue, meaning I can make a change. And I'll say 100. See how it moves up? I no longer need this. If I wanted to, I could equip it, but Porter will give me this information, so I'll just delete that. And then I'll align the column at 3. This 3D, isn't it? 3E. So the column at 3E needs to be in the same line, like this. And my alignment, I want it to be multiple this time. Okay? Meaning this to align this to align with this. Okay, now I can move out of the command. And so now how many isolated part foundations do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's count the ones from our reference drawing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we are moving together. So I control S, change my visibility graphics to fine, and we can maintain a hidden line. But when I go to the 3D thing, 3D button over there, you can see that now we have some structure elements from, excuse me, from 1 up until 5. And when we go to our south elevation there, we can see that our columns actually start from T or F. Okay, so now I can go back to my T or F, my top of footing, top of foundation view, and then we can add the proposed structural footings. So here we're proposing to use 1300 bases. So in fact, is it 1300? Let's try to use 1200. This is an assumption. We need to clarify. This is what structural design is about. We shall assume 1200, but then we'll go and run an analysis in both. If you're using hand calculations, you can try to design according to the bearing capacity or bearing capacity, the length, width, and the depth of your footing. So I'll go to my structure tab and I'll go here to isolated foundation. When I click on it, it takes me to a default of 1812450. I think this is an overkill. So what I'll do is I'll go to edit type and I'll duplicate to change, and I'll propose 1 2 times 1 2 times 300 maybe. Uh-oh, rename 1212 300 300. If I wanted to, I can just name it as F1 so that when I start annotating, you just show F1. So here, foundation thickness, I want it to be 300. My width will be 1, 2. My length also 1, 2. And I can apply. So now, you can place them individually like that, or you can place them at columns and then select the columns like that. As you can see, it's highlighted some of them, and then you just go to finish. So now you put 3, 5, 7 plus another 3 to make 10. When you go to your 3D, you can see change the level to fine. If you want it to, you can change it to realistic, for example, and then you'll be able to see your columns and your foundation, isolated part foundation from this direction. Okay, and when you go to your south elevation also, you'll be able to see them. So maybe just click here, drag this a little down. Yeah, this is beginning to appear a little like what we have here. Okay, we can go back to TRF, and then now we have everything in this view. So now we can move on to the next view where we're going to be placing some foundation walls, right? So go to the strip footing, uh, view, and then notice that the foundation walls here, they start from 1 up until 5. So what you're going to do is you're going to go to the structural wall, and here it says basic wall, but just rename it, duplicate to say foundation walls. You can leave the thickness to 200, and if you want, you can choose a different hatch pattern for them. I'll maintain the same one, and then you can say OK. So now, as you can see, it starts from 1, stretches to 5, and also it's going to a depth. And I just wanted to start from the strip footing up until the unconnected, but 800. Okay, so now meaning if I start at 1 and I go, actually I do not go, I make it hit here because I do not want it to go through. This is a better design like that. So this is why we needed to when you pay attention, this is why we needed to have this column be a little eccentric by minus 100, so that this wall and this column can have the same side, they can flush. So I'll create similar, and as you can see, I'm starting from the face because this is a better construction technique. So there's nothing there. I'll choose there and I'll place it over here. I'll cancel and I'll continue from there up until here, right? Cancel. Okay, so now from here up to here, and then from here up until there. Okay, from there I know I'm only going to find 2 columns, one over here and another one over here. Okay, cool. beginning to look like our drawing. At 4 we have 1 also, so from there to there. Okay, again from here to here. We're making a foundation system. So this goes, does it actually miss? It does miss. So there we've got a wall that doesn't meet. Okay, so from, yeah, from the middle here to maybe here, we can align it. We place it somewhere there. Okay, just click on it, select the align to from there to there. As you can see, these two are now aligned. You create similar from there to there. Okay, so now it's beginning to take shape. So this and this will also meet, that wall and that one. Okay, coolies. Okay, like that. Okay, and then now all we need are two walls, one from D and another from B. So from 2D, select this, create similar 2D, but I cannot see which one is. So I'll do this. This is A. I'll select this. This is B. This is C. This is D. Remember to save your work. Okay. Do the same here, and then you can move this out of the way like that. You can move this out of the way too, like that. You can do this on the other side also. Zoom out to have an alignment. Okay, the elbow there. Okay, cool. So now we said from 2D to 1D we'll need a wall. So select this wall, create similar from 2D here to 1D somewhere here. Okay, then it goes all the way to A like that, and then at B, so from here to here, this is the way that it is. When you go to your 3D view here, you can see what we mean. Okay, and then when we go to the south elevation, see that these walls, they are not starting from here on our section. It starts from the finished floor, just below the finished floor, as a matter of fact, up until -8. So that's exactly what we're going to do. So here, select one of the walls, right click, say select instances in entire project, so much so that when you go to 3D you can see that all of them are selected. So the base constraint will not be the strip footing. The base constraint will be it's actually strip footing, sorry. Base constraint, strip footing. Top constraint, finish floor level. Here, make sure there's no base offset. maintain it as 0. So now I'm pretty sure you saw the way that they went up. So much so that here when you go, we have what we've done here, like that. Okay. So now what I would like to do now is I would like to add a footing, what we often call a strip footing. Okay. And for 200 millimeter thick walls, I recommend 600 by 200 strip footing. So here on the structural tab, it says wall foundation. So a foundation that's supporting the wall is a strip footing. So just click on it, and here it shows you it's using about a C15, and it's saying a retaining footing. I don't want it to be 300 by 600, so I'll just duplicate and say S1 strip footing S1, but that can be confusing. So let me just say strip foot, and I want it to have, the usage is returning, I want it to have a depth of 200, and I want it to have a thickness, a width of 200. So then let's put this at 200 also, and we'll maintain the heel at 6. Then we'll apply, and then we'll try to click on one of these walls. That looks very big. It's 600. Let's try to create a section. So here I'll go to my TRF. We won't see from TRF. We need to go to the strip foot. Okay. Oh, okay. So the toe is this thing over here, meaning from here to here, 7 from here to here, 6 from here to here, 200. So just edit it to have a toe also here of 200 and apply. Yes, so overall I want my strip footing to be 600 with a toe of 200 on one side and a toe of 200 on the other, and also 200 in the middle. Okay, I hope you guys understand. So what I'll do is I'll select this and say create similar, and I'll go around and select each one of these like that. You can also do this in 3D, as you can see. When I click on this wall and create a strip footing, select this one, yeah, this one, okay, this one. So the purpose of this is actually bearing. This is not retaining. So I'll need to change that. So when you select one of them, you go to edit here, say this is bearing, float bearing, it's not retaining. Okay, this is good, because when you pour your concrete and this is how you're going to pour it, and then there's your footing plan. Make sure the view is in fine, and if you wanted to, maybe you can say shaded like that, or you can change it to maybe consistent colors, whatever you feel like, right? Similar to what we, now we've done this, and we've done this too, which is good. Okay, so for today's video, perhaps we can leave it here. So this is our structure. Should we leave it here? Should I go a little bit further? Okay, so these are solid field walls. Maybe what we can do is we can try to actually build the walls for the ground floor, and then in our next video we can try to actually we'll end the video here, giving you guys enough time to practice. Okay, make sure your grades are good. So in this video I showed you how to prepare your story heights or your levels by means of going into a self elevation and numbering them properly. That was step one. Step two, we created grid lines for identification, and then we placed our structural columns on the grid lines that we prepared, and then we placed the foundation strip isolated pad foundations just below the structural columns, and then we added some foundation walls which are being supported by the bearing strip footing. So this is what we've done in today's video. We shall carry on with superstructure walls, the foundation slab, windows, and all that other good stuff, and probably the topography. I don't know if this is going to be a two-part or a three-part video, but the way that it looks like, it may probably be a three-part video. Okay, but for today's lesson, day 3, we shall end it here with hopes of having it look like, let's open, or maybe we go to home. This one, the Selma one. With hopes of having it look like this. Okay, this is our objective. As you can see, the foundations look similar. Let me take it to 3D. You see, we have that, and we have that. So ultimately, we're gonna get there. Okay, if you've got any questions, you can send them to my WhatsApp, or you can send them to my email address, and I can be able to respond to them. Thank you so much for watching, and see you in day 4.